Through our eyes, the universe is perceiving itself. Through our ears, the universe is listening to its harmonies. We are the witness through which the universe becomes conscious of its glory, of its magnificence.
The Interplanetary Podcast. The exploration of space for the benefit of all humankind. Your hosts in England and the Netherlands, Matthew, Russell and Julio Aprea.
Oh yeah, baby.
Alan Wilson Watts.
I've not heard of Alan Wilson Watts, but he was a British writer who popularised Taoism and Buddhism and all that Zen stuff. Did you know that, Julio?
Yeah, for the Western audience. The Eastern audience were already familiar with that.
Oh, yeah, they were very familiar with it.
We found it. We thought it was appropriate for an episode in which we're mostly talking about space telescopes and how we observe the universe. Mm-hmm. Watts put forward a worldview that, after reading about it, sounds a lot like we now call mindfulness meditation, about being one with the universe. In this worldview, he asserts that our conception of ourselves as an ego in a bag of skin or an skin-encapsulated ego is a myth, that entities we call the separate things are merely aspects or features of the whole.
Now, I wonder if his quote came before Carl Sagan's "the universe has found a way to know itself." I wonder which way comes first, because they're very similar, aren't they?
Did they even know each other? Who knows?
They may have been mates. They may have lived, in some hippie part of wherever, Ithaca. Anyway, Julio, how are you?
I'm doing fine, and you?
I'm good. I've done a bit of a swap around. Poor old Lynn will be ever so upset because I've bumped her from episode 250 to episode 251 because this episode has a bit of a time constraint to it, because we've interviewed a really cool guest this week.
We are talking about the 2 flybys of Venus that happened back to back with ESA missions. And since this happened this week, we thought the sooner we cover it, the better, right? And so it happens that then I fall into episode 250, which is a special episode.
Mark McCaughrean is who we've got on. Tell us a little bit about Mark, Julio, because he's your mate.
Yes, yeah. Well, it's my colleague from ESA, yes, and we both like cycling and many other things. We have very common views on many, many things. Mark is the Senior Advisor for Science and Exploration at the European Space Agency, and he's also responsible for communicating results from ESA's astronomy, heliophysics, planetary exploration missions to the scientific community and the wider public. So he was involved with these 2 flybys of Venus that happened this last week. The missions were Solar Orbiter and Bepi Colombo. He goes in way more detail than we do right now. But these 2 flybys were 33 hours apart. And, Mark as well was working with the reception of the images taken by Bepi Colombo of Venus, and he put together a video with the soundscape music with Anna Phoebe, a musician that he works with. Yeah. And that we will include a link to that video in the show notes.
Yeah, absolutely. And Anna Phoebe, actually, I might go see her. I might go see her on the 28th of August in Totnes, which is just down the road from me, and just down the road from where Mark used to be a professor of astronomy at the university.
Indeed.
So
I mean, we are not going into his whole bio because he does that at the beginning of the interview.
He does it.
And
absolutely
way better than we could ever manage.
That was brilliant, that solar orbiter and Bepi Colombo flying past Venus. And I'm actually going to follow that science up when there's a little bit of when they've managed to collate all the data, because, of course, they've got the Atatsuki around there as well. And apparently they're going to, all the data that they collected from those 3 orbiters, 1 orbiter and 2 flybys, they'll have some interesting results, I think. So I'll follow that up nearer the time. But it's quite exciting.
Nerd.
I am a nerd. Well, as we'll see, you're the real nerd because you love rockets.
Well, I'm a rocket nerd. You're a science nerd.
Before we go to Mark, is there anything from this week's news that tickled your fancy?
Well, I thought this today, actually. I was checking Twitter and Jonathan McDowell's account, and he pointed out that apparently there was space debris collision The current hypothesis is this is a small piece from a Zenit 2 rocket, and that apparently collided with a satellite called Unai 102, and that now one could observe 37 new debris objects since the breakup, and he states that this looks to be the first major confirmed orbital collision in a decade. And as space debris gets worse and worse, and being aware of the Kessler effect that could hit us at some point and just block LEO for everyone. I think it's relevant to point out whenever these collisions happen, and it's relevant to increase the awareness of how important it is to deal with space debris.
I think there's a level of confusion here as well, because I think I saw a Guardian article this week, or maybe in the Independent, where it was saying that we wouldn't be able to launch ever again. Our access to space will be ruined with space debris.
I saw something like that.
That can't be true.
I mean, it's more the risk of more
true.
frequent collisions while you're in orbit, and then as well.
You'll lose various orbits, don't you? You don't lose the ability to access space, but you lose each orbit is a finite resource, right? So, and you could lose an orbit, which would be terrible.
Well, the most terrible orbit to lose would be geostationary orbit. Obviously, that's very unique. But as well, there are several.
There's lots, yeah. I mean, it wouldn't be good, and this Kessler syndrome as well is another one where probably really there is a Kessler syndrome going on anyway. It's just that they take lots.
It's a matter of acceleration.
They take a lot longer to unfold than the film Gravity would have you.
Certainly, it's about the amount of garbage you have in space, right? I mentioned geostationary orbit, but the main problem happens in LEO.
It's bad news, and it's probably the biggest concern, isn't it? In the short term in space debris.
Well, I mean, if you want to have a sustainable future, both in our planet and in space, this is something to be dealt with. Just like in the past, we just threw all our plastic into the ocean, and now we're dealing with the consequences. Well, it would be better to be a little bit more proactive when it comes to space debris. Well,
shout out to Harriet, who works for Astroscale, who attempting to have a go at mitigating it. What about Inspiration 4? I know that got you all riled up on on Twitter, Julio. What was that about?
So let me start about. I think it's a cool mission, right? A friend, John Krause, is the photographer. There is an altruistic aspect of it. I think the money that they make out of this mission, I think it's donated to some hospital, St. Jude's Hospital. You know, I can be very, what's the word?
Grumpy.
Not grumpy.
Grouchy.
Precise.
I think that's how I describe.
I would call myself precise.
Okay. Sorry, precise. That's what I mean.
They claim to be the first
pedantic. There we go.
all civilian crew to orbit, and I have a problem with that because if you do a little bit of research, they are not the first civilian crew to orbit. I don't know for a fact which one is the first all civilian crew to orbit, but at least Expedition 8 with Michael Fall was all civilian. Neither of these guys were part of the police or part of the military, right?
But that falls into this is where it falls into my definition.
But let me finish. Let me finish.
Okay.
So the concept of civilian space, there was a big deal of NASA being a civilian agency, as compared with the Russians back in the Cold War, that their astronauts, their cosmonauts, were military. NASA's astronauts were civilian. And there was a big statement from NASA to say the first man on the moon is civilian. It's not military, because we come in peace for all mankind. So in this context, in space, civilian has been used for several decades, including one of the moon landing. So now it's distorting the meaning of that word. And I know that you being native, you are supposed to know your language better. But when I don't know the meaning of something, I go to the dictionary. And if in the dictionary it says that the civilian is someone that is not part of the military or the police, then the claim to be the first is not true. And I would have no problem if they call themselves the first non-professional crew to orbit, the first amateur crew to orbit. That would be accurate, because in theory they are not paid astronauts. They are tourists, right? They are space tourists. But why call yourself first all-civilian crew to orbit when it's just not true?
It does come down to definition of civilian. In actual fact, we tell off our undergraduates when they use the dictionary to define terms, by the way. You're not allowed, it's a bit of a faux pas in academia.
What do you mean?
To use the dictionary to define your terms that you're using in your dissertation, for example, it's frowned upon. And rightly so, because you have, for example, you have digged out a definition that's not all encompassing. And one definition with civilian, which is quite strong, is the fact that it's people who aren't in the fire brigade as well. And so you could say that the colloquial use of civilian is when people aren't part of a sort of organisation that you're expecting to be doing something. So NASA are the expected people to put people into space. So anyone who's not working for NASA would be a civilian, because they're not working.
But
for
you
NASA.
see
so
where
it's a colloquial definition.
But can you see where there was a big deal of calling NASA a civilian agency?
Yeah, no, I get that. I get
a big
fact.
deal
Yeah.
In the particular case of Neil Armstrong, to be a civilian astronaut, or later on,
I agree.
Later on, mission specialists for Space Shuttle were also civilians. You see,
I do agree. I do agree with you, Julio. I think it's silly, but at the end of the day, it's just PR, isn't it? I can't get too het up about it. I know what they mean. It's the first time that 4 people have gone up who aren't trained for some mission and aren't part of an agency. They're not part of NASA. They're not part of Roscosmos. So they are all. Whereas Mike Foale, he might have been a civilian, but he was still a trained astronaut who was doing it on a mission. Whereas this is the first. I guess they just couldn't think of a term to call it that the public could relate to.
It's just the American.
They can relate to civilian, can't they?
Tolerate the American aggrandizing marketing. Meaning, like when you go to some random town in the US and you find a burger joint in the corner and it says "best burger in the world." Well, I like to contest that. How can you verify that you're the best burger in the world? You see?
Oh, come on, Julio. We have it in this country where every single sort of town, you go to Nottingham and there'll be a pub that will say the oldest pub in Britain. And it's like, okay, so there's loads of towns that have the oldest pub in Britain. So if you're ever in Britain and you're drinking in what is supposedly the oldest pub, yes, it will be an old pub, but I doubt it will be the oldest pub in Britain, even if it lays claim to it.
I went to a wedding in Britain, and I actually went to the oldest pub in Britain.
Where was it? What town?
I don't remember the name of the
town. There you go.
Maybe I want to hold people to a higher standard than cheap marketing. And what takes me off, again, they can call themselves whatever they want. But Time Magazine, who is apparently marketing all of these, it's supposed to be a journalistic enterprise. And there is a journalist there as well writing about them. And I would expect journalists to fact check and to follow formal meanings of words. Imagine if later they want to claim
You expect journalists to do that? Oh my God, you've got far too high. I actually think a bigger problem was a load of writers and journalists got a kind of invite to interview the journalists that are interviewing the Inspirational 4 astronauts. So it's like not an invite to interview them, but an invite to interview the journalists. It's like, what? You want me to write about you writing about the inspiration?
And then
like
to interview
really
a journalist who's not even fact checking his own claims.
Yeah, exactly. So it's even worse.
But there's even I saw that there's even a Netflix documentary. They are filming a Netflix documentary about the training for this mission.
Yeah.
And okay, maybe I'm too much into this business, but if you tell me that you're going to film a documentary about people training for a space mission, I would prefer to watch 1,000,000 times a documentary on Matthias Maurer and what's the name of his mission that he will go?
Crew 3.
Cosmic Kiss was the name of the mission, but it's Crew 3, right?
Yeah.
I would prefer 1,000,000 times to watch that documentary of real astronauts preparing for a real mission to spend months in space with EVAs and such than just random people going on for 3 days on a capsule and then coming back. And
there'll be some weird kind of hippie stuff with them as well about how they have to get into the flow state when they get up there. And I would say it might even be
I guess it's just not meant for people that actually understand and know about space. Is it that it's not for us as an audience? Is it just for the general public?
For us. Yeah, what they've done is they've looked at their audience and they've based it around that. That's fine, isn't it? It's a bit like we know our audience and give them really clever interviews and don't dumb it down for them because we know our listeners are well clever.
Well, we have the oldest audience in Britain. And the smartest. Yeah. Now, what looks bad is the Starliner delay. Doesn't that look awful to you? Not at all. I mean, you know my take. This is supposed to be a test mission.
Oh, I love this.
What can I tell you? It's a test mission.
You're worse than journalists. You give engineers such a good ride. No. If there's something wrong, you should take. Come on, there's miles behind schedule. What the hell?
Okay, but if you're going to launch and you find some issues with some valves, you better not launch.
Oh, well, obviously, but there shouldn't be issues with the valves. I'll tell you what, if you were in the music industry, you'd be doomed. The gig has to happen on the day that the gig was organised. On Anne Phoebe's gig on the 28th, it will happen on the 28th, and nothing will break. No one will get killed.
This is not the launch of the Voyagers in which you have an exact launch window. This is a test flight. And it's better to do it when it's ready.
I know, but if they knew that they had to launch on that day, they would have to do it. It's the difference between sound engineers and rocket engineers. We're just better, basically, Julio. Anyway, enough of this banter because this is a very long interview. Yes. It's a long interview, and I have to edit this before tonight.
But it's a long interview, but I think it's worth it. I think
it's definitely
Mark has a lot of knowledge and lots of opinions too.
He's a lovely, lovely bloke. He happens to share 2 of my favourite albums come up during this conversation. So that's that as far as I'm concerned. He's a legend.
Okay, let's go to the interview.
Écoutez.
The Interplanetary podcast, putting the ace back into space.
Julio and I are joined on the podcast by Mark McCaughrean. Is that right, Mark? Have I got it right? Have I butchered it?
Yes. Spot on, Matt. Spot on.
Welcome to the podcast, Mark.
Hi, Mark.
Before we start, because you're such a... You've been in this game for some time, can you give us a very quick and precise rundown of your career?
A prolific career, I could say.
Prolific career, yeah.
Yeah, absolutely. So actually, I was just thinking a couple of days ago, was it last night? I was cycling past the Heineken brewery, which is on the outskirts of Leiden, and I love the smell of the hops as it kind of comes off the brewery when the wind's blowing the right way, because it reminds me of the day I went to university in Edinburgh in 1979. I walked out of Waverley Station in Edinburgh, and there's a big brewery on the west side of Edinburgh, and that when the wind's blowing right, which mostly is from that direction, the whole of Edinburgh smells like a brewery, which is actually quite nice. So I was thinking of that because I'm just about to send my son off to university in a couple of weeks. So sort of, but slightly poignant moment. So that was 1979. I went to Edinburgh to do astrophysics as an undergraduate degree. I was already, very interested in space, and I thought, well, how do I get involved in space flight? Want to be an astronaut, having watched Apollo and all that sort of thing. And thought about doing a PhD I was offered one at the University of Leicester to work on X-ray astronomy, which was more space than ground-based astronomy, obviously. But my PhD advisor, who became my PhD advisor, I was working on a project with him, and he said, well, if you stay with me, you get to go to Hawaii, you get to go to Australia, we'll do ground-based astronomy, and I know an astronaut, so I'll introduce you. He told the truth about going to Hawaii and Australia and all these sorts of places. He lied about the astronaut. I never got introduced to the astronaut. But so that was the beginning of my career. I worked in infrared astronomy, which is predominantly, in those days, a ground-based endeavor, using big telescopes in Hawaii above all of the water absorption in the Earth's atmosphere. And we built one of the very first cameras in the infrared. We used military detectors that were available actually to do with the Star Wars program in the 1980s. And we put the first camera on an infrared telescope for astronomy in the mid-1980s. And that sort of set the tone for my career, because I stayed then involved in infrared imaging in astronomy. I after my PhD, moved to NASA Goddard Space Flight Center in just outside Washington, D.C., and worked there with a guy called Dan Gazzari on an infrared detector at longer wavelengths, thermal infrared, 10 microns wavelength. And from there, I got involved in Hubble, because people at that point were still looking for people who knew about infrared imaging, because it was very new. And I was one of the only people in the world that had actually done this stuff. So I then went to work on an instrument called NICMOS, which was the second generation instrument for the Hubble Space Telescope, which was due to be launched around the end of the 80s. Of course, there was the Challenger disaster in the mid-80s, which delayed everything on Hubble. So I moved to Arizona in 1989, and started working on NICMOS, this instrument, part of a team. And then when Hubble was launched in 1990, Hubble had a problem. Hubble had a mirror that didn't work properly. So recovery effort was put in place to build what would you call it? Contact lenses, corrective optics for Hubble, which would then sort out the optics. But that actually meant our project was delayed, and a whole bunch of us were fired with very little notice to take the money back. At that point, I moved to Germany. Took a while to get a job in Germany. Took a while to get a job anywhere. But I moved to Germany, and then again started working on ground-based infrared cameras at the Max Planck Institute for Astronomy in Heidelberg. And that then, that was to do with big telescopes in Spain, which we had, and in South America. And at some point, somebody gave a talk then about this thing called the Next Generation Space Telescope, a new big telescope that was being designed for space that would be focused around the infrared. And he said, would you like to be involved? Because this is your skill area. And that's how I got involved in what's called the James Webb Space Telescope. And that was in 1998. So I was in Heidelberg. I then worked in Bonn. I worked in Potsdam for a number of years at the Astrophysical Institute in Potsdam. Moved back to the UK for a short period of time. I was a professor at the University of Exeter doing astronomy. And then the chance came to actually come to ESA and sort of join all the dots up and be involved in space. And I'd been on some ESA committees and people knew who I was. And then I moved to the European Space Agency in 2009 and have been here ever since. So we can maybe go into a bit more detail later on, but you asked for it to be short. It wasn't short, but I've moved around a lot. So
my very first when I went to university was at Salford University, and that also stinks of hops from the Boddington's brewery as well. It's like,
Julio knows the place. I'm sure it's just on the outskirts.
I
of
have
Leiden,
not. You will have to take me by bicycle.
No? It will be. It's remarkable. You know how smell can be, right? I mean, smell is probably the most instantly nostalgic sense. You can listen to a piece of music, it can transport you. You can look at a photograph, but somehow smell just goes right into the middle of your head and can transport you years into the past in an instant. Remarkable. So I cycle that way quite a lot, actually.
That's so true. I have a comment and a question. The comment on the Hubble, by the way, months ago, we had in the podcast one of the astronauts that actually was on the mission that deployed Hubble. So Hubble is very, very recurring topic here. Kathy Sullivan. Yeah, of course, it's such an important spacecraft for everyone. You can say that it changed. It changed the whole space outreach, right? The images that you could get out of Hubble. The question I had is, when you mentioned the instrument, you said it was a second generation instrument. What does that mean?
Well, when Hubble was launched in April 1990, it had instruments on board from the collaborators. So the European Space Agency had an instrument on there called the Faint Object Camera, for example. There was a wide field planetary camera, and then there was the high-speed photometer, for example. There were several instruments which had been built over years, installed. But Hubble was always meant to be refurbishable because it's in low Earth orbit. The astronauts could visit it with the shuttle, take boxes out and insert new boxes. So the idea was always that you would put new instruments in as the technology improved. And NICMOS was a classic example of that because the infrared detectors in it did not exist in the end of the 70s when all of this was being put together, but it became available in the 80s. There was another instrument which was being built at the same time, so there was one, it was a bit of competition between the two to see who could be finished first, but they both got put on the same shuttle refurbishing mission in the end. But in the meantime, there was one to install this thing called CoStar. And CoStar took out one of the instruments. It took out, if I'm right, it took out the high-speed photometer. So that was actually never very useful on Hubble. You had to sacrifice something in order to improve the optics. So you pulled out one of the instruments, slid in the CoStar box, and CoStar then deployed little mirrors above all of the other instruments. So the light that was coming down from the telescope to the instruments was intercepted, relayed through a couple of mirrors, which just put a little tweak on the optical figure to correct for the main mirror. And then that light passed into the instruments. And instantly, they could all see properly. The main camera system was actually plugged in sideways above those mirrors. And they just put a new one in. So they removed that completely and shoved in a new version. Yeah.
Yeah, legend has it that that's based on a shaving mirror, or that was the inspiration. Someone was in the shower and...
Yeah, I've heard the story that it was to do, because I was around at that time and never quite got the full picture, but it was also to do with the idea that they were in a hotel in Germany, and it had to do with where the shower head actually was mounted on the wall, that the shower head could be moved up and down. Because if you've ever been in an American hotel, they have this pipe that sticks out of a wall, and it's completely immovable, right? And so you can't actually adjust the height if you're a taller or smaller person. And that was part of the legend I heard, and I don't know which is right, but they were in a German hotel and said, my goodness, you can move the shower. And that was sort of the idea of deploying the mirror up and down. But there were some weird and wonderful ideas for Hubble about even putting a gas-filled balloon inside the main tube, which would add, if it was just the right shape, that balloon would then provide the same correction. I have to say, I had an idea which I would have been famous for another reason completely if it had ever happened. And that was that we knew that we were going to be installing this infrared instrument. And this infrared instrument would profit from the telescope being a lot colder than it was. So the thing is that Hubble's in space, but its mirror was polished at room temperature on the ground. Okay, and so to keep the mirror in the same shape as it was polished, it's actually heated. It's actively heated to room temperature, that mirror on Hubble. And that means that the mirror is glowing in the infrared. And so we thought, well, okay, we take the opportunity, since we're going to put corrective optics in anyway, why don't we just turn all the heaters off, let the mirror cool down to whatever temperature it gets to. That means it'll be better for the infrared. But then we'll correct that shape, because the shape's wrong anyway, right? What shape are we preserving by keeping the temperature warm? And then somebody pointed out that actually, unlike on the ground, where telescopes, the mirrors in telescopes on the ground more or less just float inside their mountings to avoid any pressure points, so they keep their shape. Hubble, that wouldn't work. No gravity, the mirror would float around. So Hubble's actually bolted down in 3 places, the Hubble main mirror. And somebody calculated that if we turned the heaters off, there was a chance that you would put enough thermal stress in the mirror that it would snap. And so, if my idea had worked, I probably would be famous for a very bad reason. So fortunately, that wasn't followed, but I didn't break Hubble's main mirror. But.
Can you imagine?
Yeah, this would be a very different interview, wouldn't it?
Yeah. Speaking from prison.
By the way, you're making a point on the temperature of the mirror on the Hubble, but the James Webb is made to be infrared. So if I was listening to some interview the other day in which one of the big points with these mirrors was to design them on the ground to account for the thermal distortion once it is in L2.
Yeah, it's actually even a bit cleverer than that. The James Webb Space Telescope, even before Hubble was launched, the community knew that some of the questions that would remain unanswered, the big questions, had to do with moving to the near infrared. So, for example, we know that galaxies on the largest scale are receding from us due to cosmic expansion, the redshift, or the universe is expanding and dragging the galaxies with it, if you like. And that light gets shifted further and further into the red and end of the optical. And at some point, the most distant galaxies are going to not be visible at all. They're only going to be in the infrared. So if you really want to see the galaxies right back at the beginning of time, you need to build an infrared telescope. It's also good for what I do, which is star formation, looking in places where planets are being born, going around young stars, completely shrouded in gas and dust still, right? The stuff they're made of surrounds them, and actually visible light doesn't get out. But the infrared, night vision, if you like, can see right into those objects. So that's why I'm involved in infrared astronomy, looking at young, cool objects surrounded by dust. So how do you build an infrared telescope which then doesn't glow at the same temperatures, at the same wavelengths that you're trying to observe? Infrared astronomy on the ground has been likened to observing in broad daylight with a telescope made out of fluorescent light bulbs, right? It's just, everything's glowing, blazing at you, and you're trying to see those tiny, faint things in space. So the way the JWST works is you basically say, well, let's cool the mirror down. The way it'd been done in the past is you build a little small mirror and stick it at the bottom of a cryogenic vessel and cool it down actively. But that can't be very big, right? So that was the ISO telescope that the European Space Agency built. You could also build a big mirror and just sort of let it cool down as much as possible by making sure that it never saw any sunlight. And that's how Herschel worked, for example, ESA's Herschel. So JWST takes that to the next scale. It says, well, if we build a giant sunshield, size of a tennis court, stick the whole observatory behind that and make sure it never sees any sunlight, it will basically cool into the darkness of space. But then, as you say, how do you design the mirrors on the ground to have the right shape when they go into space and get very cold? And the way it was done was the mirrors are made of metal, they're made of beryllium. And so the beryllium was shaped in hexagons, because we have 18 segments to make this giant mirror, and then polished. And then it was put into a cryogenic chamber on the ground with optical equipment, cooled down to the temperature it should be at space. And then by measuring the shape and how wrong the shape was, okay, because it changed its shape when it cooled down, measure the shape and how wrong it is, take it back out, warm it up, and then polish the negative of that into it. Polish the inverse of what you want it to look like so that when you cool it down, it goes into the place where it's supposed to be. Take it out, iterate a few times. And so
I assume you have to iterate quite a bit.
Yeah, well, actually, I mean, the models were quite good, and beryllium doesn't change its shape very much. That's why it was chosen. Beryllium is two things: really light, so it means you can build a big telescope without a huge amount of mass. But also, it doesn't, the thermal coefficient of expansion, how much does it change its shape, is actually almost zero between room temperature and 50 degrees Kelvin. So actually, you don't have to change the shape very much. The other problem with beryllium is that it's bloody poisonous, and so it's an absolutely horrendous thing for health and safety for manufacturing. So those mirrors were not cheap to make, and they had to be made under incredible clean conditions, keeping workers away from stuff. So these big machines were bought in from Japan to do all the polishing and everything, and basically scrapped at the end of it. They could only be used in that one cycle.
Because of the contamination of the beryllium.
Yeah.
So
exactly.
Why do they look gold? Beryllium
well,
sort of gold, is it?
So in the end, the beryllium is it's a nice material for all of the reasons I described, but it doesn't reflect visible light very well, or infrared light very well. I mean, it's kind of a grey metal when you see it when it's polished. So you just put a tiny thin coating of gold on it. Now, gold obviously doesn't reflect at visible wavelengths all of the wavelengths equally. That's why it looks yellow, right? Something that would be reflecting all visible wavelengths would look white. And for visible telescopes, you'd maybe use silver, for example, which is a very white-looking metal in the visible. Gold, on the other hand, is completely flat in its reflectivity in the infrared. So if you had infrared vision, if you were a snake and you looked at JWST, it wouldn't look yellow at all. It would look completely white because it's really effective at reflecting all those wavelengths equally. But it's a tiny, tiny thin layer on top. I had a sort of joke at some point during the last administration that the ex-president of the United States would suddenly look at the telescope and say, "What, you mean it's not real gold? Make it again, solid gold." At which point it will weigh, a few thousand tons, but then it could be called the Trump telescope. Well, I've named him now, anyway. Yeah, but fortunately he's gone, and that didn't happen.
By the way, you mentioned briefly the Sunshield, and I watched the animation on the deployment probably 2 days ago, and it's giving me nightmares from an engineering point of view. I don't know if I can sleep between now and when it's fully deployed.
Yeah, I mean, again, we're trying to cram an enormous telescope into a small space. I mean, small, relatively. The Ariane 5 payload fairing is big, but it's not 22 meters across. So the telescope itself is folded up. I mean, it's kind of like an old kitchen table. So the wings are folded down, and then we fold the wings out to make the full telescope. The secondary mirror has to fold over into place. The telescope actually has to deploy away from the spacecraft part so that it's not in thermal contact with it. Otherwise, it would never cool down. I mean, it's in physical contact, but it's very thermally decoupled. But at launch, it's held together so it doesn't fall apart during the launch. You have to deploy the solar array. You have to deploy the antennas. But as you say, the big, scary thing is this Sunshield, which is 5 layers of very thin, effectively mylar material, so a metallic material. And it's like a sail. I mean, it's basically pulled out on cables and cords. All 5 have to come out bit by bit by pushing arms out, and the wings basically fold down to make it, to deploy at half, and then you pull all the sheets.
And the 5 layers, the 5 sheets are all stuck together, and then you have to distance them from each other.
Yeah, well, since we're talking about the engineering, it'd be a funny thing. You have to distance them so that there's obviously they can't touch each other, so there's no thermal conductivity. Each layer effectively reflects back a lot of the light, and you reduce something like a few megawatts on one side to milliwatts on the other side once you get through the 5 layers. I mean, that's how good that Sunshield is. But the layers actually also have to be separated, but they also have to be slightly angled, opened wide, so that effectively the light just doesn't bounce back and forth between the layers. It ultimately works its way out and goes out into space sideways. Those layers are aligned to within millimeters of the tolerance that need to be, so that the sun never pokes over the edge. But you couldn't make it. If you made it way bigger, then it would just mean a bigger telescope. So everything has to be aligned perfectly.
Looking at that animation, it reminded me when you make a bed and you put the first sheet against the mattress, that you have to make it.
Yeah,
that's the image.
It's for spacecraft engineering, it's an incredibly analog-looking thing, right? A very big floppy bit of material being pulled out. Normally, you think of hard bits of metal going clunk, click, bang, but no, this is all. Yeah, it is. But we've tested the crap out of it. So yeah.
Here's the question: is that does a lot of that unfurling and a lot of the kind of getting it into its space configuration after getting it out of its cramped fairing on the Ariane 5, does that happen? That doesn't happen at the Lagrange point, though, does it? Does that happen in? No,
it's along the way.
Yeah.
Does it
it's on the transfer
while it's actually transferring, or does it just orbit the Earth for a bit so that if something does go wrong, there's a chance of fixing it?
It's direct injection to L2, so we go.
But there's a chance. There's a chance of what, Matt? It's not. This is not like Hubble. It's not designed as a refurbishable. So even if something happened while in lower orbit, you cannot send astronauts to fix it, right?
Well, you give it a go when it's 15 billion, right?
Well, it's a very different. It is different to Hubble in that sense. I mean, everything to save weight, to save, to make it as big as possible, but within the weight limit. Keep in mind, Hubble is over 12 tons, and it's got a 2.5 meter main mirror. JWST has a 6.5 meter main mirror, vastly larger structure, and only weighs 6.5 tons. So the way that it's engineered is not to be refurbishable. However, there was a point in the mid to probably early 2000s where somebody said, well, look, we need to find a role for future human exploration, right? We need a destination. And, are we going to Mars? Are we going to asteroids? And one of the places people said, well, let's go to L2. Let's service our very expensive assets out there. So there was a point at which a grapple fixture was supposed to be put on JWST, so that in principle, if a crewed mission went there, we could grab a hold of it. And then, as Julio implies, then do what exactly? Because none of it is designed to be refurbishable. So it's all incredibly tightly integrated in the back end.
It's like trying to fix an iPhone versus trying to fix an old car.
Yeah,
I mean,
exactly.
The Hubble, the Hubble parts, you had a set of instruments, and it's made so that astronauts with their big, clumsy gloves can do something there.
Yeah. I mean, so
anyway.
But just to finish the point, we go directly to L2. So we launch, we don't loiter in low Earth orbit, we go straight out, and then on that journey, and so that people know where L2 is, it's 4 times further away from the Earth than the Moon. So it's not exactly close. And we don't go super fast out there, because if we do, we just go straight past it, right? We kind of have to get out there and stop when we get there. And there's not big retro rockets on JWST or something. So it takes a while, this journey, deliberately, so that we arrive there at kind of 0 speed. And we don't actually end up at a point in space. Nobody sits at L2. We actually orbit around it in this giant orbit around that location. And so, the instrument, the telescope will unfurl. The solar panel has to unfurl first because we need power, right? The batteries will run down, so you have to get some power. And then you start deploying stuff. You open up the Sunshield, you deploy the telescope, you put the secondary mirror over, and all of that goes on over weeks as the telescope's cooling down as well. So one thing people need to realize about JWST, do not expect to see images soon after we launch, because it takes actually 6 months to commission the telescope so that it fully cool down. We talked about the main mirrors, for example. Those 18 mirrors are all individually on actuators. They can all move up and down. They can all tilt. They can all rotate slightly. And we can even pull on the back of all of them to change their center of curvature slightly. So although we've designed it to be all aligned, when we get there,
you have to calibrate.
We have to do all the calibration. We start taking pictures of stars. They'll be completely there'll be 18 pictures because the mirrors won't be lined up. Then we have to bring the 18 images together. We then have to tweak every one of them to make them all perfectly sharp and in focus, and make out of 18 individual mirrors, make one coherent 6.5 meter mirror. And if we don't do that, then we don't kind of get the sharp images that we built the telescope for.
And now I have to defend my rocket a little bit here, because you guys mentioned the cramped space under the fairing. But in fact, back in the day, Ariane 5, when it was chosen for this mission, one of the advantages was the volume that it provided under the fairing.
Absolutely.
It's
the volume,
that was
and also
amongst what the best you could get.
Yeah, it was the volume. It was big, exactly. I remember when we were talking about
reliable.
This, we were trying to negotiate with NASA. What can the European Space Agency bring to the project? What can the Canadian Space Agency bring? So it's an international collaboration. And we said, let's put an Ariane 5 on the table. And of course, in America, that was, NASA liked it because, I wouldn't say it's a free rocket. Somebody's paying for it. But Ariane 5 was reliable. It's become way more reliable, of course, in the meantime. But it has been a political football over the years, right? Certain congressmen have said, how can we launch this big US asset on a European, a smelly French rocket? I mean, that's a bit, if you want to edit that. No, that's fine. There was definitely politics involved. But that's how these big international collaborations always work, right? Give and take. So I can tell you, NASA are really happy to be flying on Ariane 5. And so
the director of science was in Kourou for the last flight of Ariane 5 a few weeks ago. He seemed very happy with what he posted online publicly.
Yeah.
And I have to say, for me, it's one of the launches of the decade on an Ariane 5.
We've been talking about this launch as potentially the most stressful launch of all time, right? It's so much is riding on it. It just seems, I don't know, as someone who lives within the European Space Agency catchment area, I feel as though it kind of puts that responsibility even on me, and I've got nothing to do with it.
Yeah.
I think every launch is stressful, no matter on what rocket you are, no matter on what company you are. I think if you are involved in the operations or the launch or in any way with the rocket, you sleep better the night after, of course, but it's part of the game.
I remember a few years ago, we were doing media for one of the ExoMars launch, for the first ExoMars launch, and there was a film crew, and they said, he came to ESOC, and they said, can we film you while you're watching the launch? I wasn't physically at the launch, I was in Germany. And they had a camera in my face, and the rocket went up, and it was like 10 seconds after launch, and they said, "So, how do you feel now?" And I said, "There's a long way to go yet before we know this thing works." It's like, it's not just getting off the ground which is important; it's everything that happens after that. Very stressful.
I had a launch on the launch of Cryosat 2. It launched on the Dnieper rocket, which is a rocket that you launch from a silo on the ground. And basically the rocket is catapulted into the air. And once it's in the air, you have the engine ignite. So there is a fraction of a second that is the longest second you will have in your life, in which your payload is just hanging in the air. And if that engine does not ignite, that's it. I have to say that that one was immediate relaxation after I saw that ignition. But anyhow,
I've got a question though. If there was a mishap, at launch, at deployment, etc., presumably you've designed the James Webb Telescope, like the actual that's the hard bit. Would you actually all build a new James Webb and get it up, or would you go? Well, let's just build the next generation now.
It's a really good question. It's a good question. It is a tough question, and obviously we've had experience with this with other missions at ESA, where we have actually had failures and we've rebuilt it. Cluster, for example, was on the first Ariane 5.
Cryosat, like I mentioned,
Cryosat as well.
It was Cryosat 2.
Yeah, and then we went and rebuilt those things.
In the case of Cryosat, it was 100 millions around. I'm not giving you the exact number, but we're talking about the different magnitude here. Huh?
Yeah. I think that obviously the cost, everybody says, why do these things cost so much? Well, it's people. It's how long it takes to build. It's people machining bits and pieces, assembling bits and pieces, testing bits and pieces. So obviously we've done much of that testing to prove that the hardware as built is able to perform the way that it should. So we wouldn't have to do that stuff again, at least, not the kind of proof of concept testing. You could go ahead and say, well, we know this design works, so build it. But it would be many years of work in a very linear way of, for example, making the mirrors. The mirrors took years to build, just not because they were being tested, but because it just took years to build, right? Making them, machining beryllium, making beryllium powder, compressing it, machining, polishing, testing, cryo polishing. Yeah, I don't know how that would work out. It's a fascinating question. I've thought about it many times, and I just don't want to think about it. But
I think my take is, given at the speed that things are moving in terms of space transportation and space manufacturing, I see a future. Mark, you might. I would love to hear what your thoughts are on that. But I see a future in which space observatories would be built or at least assembled in space, because you can see how we have reached a level of sophistication in order to fit inside a rocket that would be super simplified if you could just build the thing while you are already there.
Yeah, we have had, we've had proposals at ESA to do on-orbit assembly, so X-ray telescopes, building a giant X-ray telescope. And actually having components even put together, but then even not joined together, but floating freely at distances from each other. And it's just sort of never worked out that it turns out to be, because you're ultimately reliant on other people's technology working, right? It's not under your control whether those launchers will be ready at the right time and whether you've got the people there and whatever it takes. And I think something like JWST, if you just to say, well, let's launch a version of it where the Sunshield's already deployed and the mirrors are already deployed and we just plug and play them, I just don't think that would work, to be honest. I mean, if you think about the massive amount of work that has gone on in basically just putting it together, all of the wiring, all of the piping, all of the stuff which connects the warm side and the cold side and the electronics, it's utterly remarkable. That's where the money goes, right? It's people working day after day after day doing that stuff. So whether it could be plug and play in space, I don't know. But there are certainly dreams about it. I don't know. One of the weird things, and we you're in the rocket world, and we're aware of all of the stuff going on in new space and big launchers and so on. And I look at all of this stuff, and I have to say I'm a bit cynical about it, because instead, in the end, it's the payload that counts. I don't actually care about rockets very much. Sorry, Julio, but I mean, it's obviously kind of cool, but it's
okay. It's okay, Mark. I see you. What you guys do as ballast.
Yeah, exactly. Yeah, I know. You engineers, you just launch some concrete, right? But the payloads are fantastically complicated, and in fact, they have to be. Else, we're not asking challenging questions, right? We're not doing the most challenging things. So all of this idea that we'll have big rockets and they'll just launch loads and loads of dumb payload into space. I mean, just as a sense of measure, and again, I just put it in scale. Everybody says, wouldn't this be easier with now we have all the much cheaper launchers, much cheaper than Ariane 5? You know what? Ariane 5, I don't know what we've actually paid for it, but order of magnitude is 150 million, right? JWST is 10 billion, round numbers. So this is 1.5% of the total cost. I don't care how cheap the launcher is or how expensive it is. I just don't care. It's not my problem. I want it to be reliable. I want to make sure it flies, and I want all of the engineering in that to ensure that it does, right? That's the most important thing. All of this stuff about, new rockets being cheaper, frankly, to me, the only rationale for them being cheaper is when the payload is much cheaper than that. And there's only basically two forms of payload that are that cheap. One is water. Just launch a bunch of water into space. And humans. Humans are such dumb, cheap payload, they'll actually pay for themselves to go into space, as we've witnessed in the last few
humans are bags of water. So.
Well, exactly. Yes.
Yeah.
So at that point, cheap rockets count, right? But for the kinds of things I'm interested in, I'm not glorifying the expense of our missions. I'm not saying it's great that they cost lots of money, but it's because it's people doing years and years of dedicated work. They're not gold plated, although JWST's mirror is literally gold plated, but that's not how it works, right? It's people building incredibly complicated machines, and you can't
It's not the material. Yeah. It's not the material, but that you're building something that is pushing technology to its limits.
Absolutely.
Into unknown areas.
Absolutely.
And as you are developing that technology, sometimes you find issues and you have to backtrack and rework them in another way. It's part of technology development. It's part of the business of being at the edge of what we're doing, innovating. So, I mean, we have nerded out on the technology behind these telescopes and the rockets for quite a bit now. I have in order to more or less conclude with the Hubble and JWST part, one question I had was, many times James Webb is being portrayed as the successor or follower of Hubble. But Hubble, again, I'm not an astronomer, so I'm going to butcher this, but Hubble is more for optic observations, right? And James Webb is designed for infrared. I know I'm oversimplifying, but how then is that connection between the two of them?
Yeah, that's a great question, and it'll come up a lot, and because it's kind of a cheap journalistic thing to say, right? I'm not saying you doing that, but the journalist will say the successor to Hubble, the James Webb Space Telescope. In some sense, yes. In linear time sense, yes, it comes after. It's the next big observatory. The wavelengths do actually overlap. There are, the Hubble can see in the near infrared, and JWST's prime spot will be at that wavelength. JWST then extends to much longer wavelengths, which is great. And Hubble extends to the visible, as you say, and also down to the ultraviolet. And in fact, the ultraviolet probably would be, the big loss when Hubble finally ends, because we have no other telescope which can access that. Whereas at least you can do visible astronomy from the ground, right? But the ultraviolet's difficult. So JWST it's a completely different technology. It's completely different detectors. I mean, so in some ways it's not a successor. Some of the science goals overlap. Some of the science goals of JWST, we kind of knew that Hubble wouldn't be able to answer them because, again, of the wavelengths involved. And Hubble has thrown up lots of very interesting questions itself during its more than 30 years of life. So, for example, exoplanets. Exoplanets were never part of the Hubble case to begin with. We didn't know of any, and they were never part of the JWST case even, because the first ones were only discovered in the mid-90s. But now exoplanets are a huge focus for JWST, and we should be able to measure the atmospheres of planets orbiting other stars. We've done some of that with Hubble, but JWST, better wavelength, bigger telescope, collects more light, will do some great work there. So it is extending, but I think there's a sort of more metaphorical level. If you think about Hubble, it's been in place for more than 30 years. That's several generations of school kids that have gone through looking at those glorious color pictures on the walls in their schoolrooms or in their textbooks or in movies. It's been hugely influential in that sense. And there's even an argument in certain communities that says that Hubble, it has a human story. It has a redemption story even. Hubble was broken when it was first launched, and yet humans screwed it up, and humans went and rescued it, right? And the whole idea about the astronauts going out there and you see them floating around with, as you say, with the big gloves, pulling hardware out, that brings a real connection to Hubble. And in fact, there's a whole community of people who don't want to see Hubble ever end, and we kind of slightly, I don't know, it's not derisive, but it was with a slight kind of nod. We call them Hubble huggers, right? The people who don't want to let Hubble go. And there's quite a few of them in the science community as well, but there's this real emotional attachment to Hubble because of its longevity and this redemption story. JWST is designed for a minimum of 5 years and will have enough fuel on board for 10 years. There's a really technical reason why Hubble can continue to operate in low Earth orbit, because it's inside the Earth's magnetic field. It can use the Earth's magnetic field in ways to keep it running without fuel on board. JWST is way away from the Earth's magnetic field, or in a much lower intensity part of it. And so we need fuel on board to actually maneuver around a bit. So there's a finite lifetime. And the last part is the creative part. If you think about Hubble has taken astonishing images, right? And it's those that draw people in. And many of my friends who are spectroscopists and so on say, yeah, it's the images which capture the imagination, even if they're not necessarily the science, or they have science, but a lot of the science comes from analyzing, breaking the light apart. And the real question is, I suppose the question is, what will JWST do for creative, glorious color pictures? And the good news is it'll do amazingly well, because JWST is loaded with lots of different filters for isolating the light from specific parts of the spectrum in the near infrared. So there'll be lots of features where, hydrogen will be glowing, or helium over here, and then oxygen and dust, and molecules. And so by isolating those lines, we can make great science, because we can just see that feature. Where's the dust in this region? Where's the molecules in this region? Where's the hydrogen? But that makes for beautiful pictures as well, right? Because you can assign the colors, R, G, and B, to those different wavelengths. So other infrared missions which have been flying in the past have typically not had such a range of filters, and then pictures have looked kind of muddy. Now, again, full disclosure, the say where people should look at JWST images and say, wow, Hubble has a round primary mirror, okay? It's a very clean profile, and that makes for incredibly clean images of bright objects, of stars, okay? Diffraction spikes, these crosses, and then the bright stars, very kind of nativity play, Christmas card kind of pictures of stars with diffraction spike. I don't know why that's in nativity scenes and Christmas cards, because that's not how humans see it. We never see that cross, but Hubble does. JWST has 18 mirrors, and they're all hexagons. And there's going to be a heck of a lot messier, what we call point spread function, what a bright star looks like. It's going to have all sorts of blur around it because of those 18 mirrors. For the scientists, it's going to be fine. We know how to deal with that. But the pictures are going to look kind of, I don't know, dirty is the wrong word, but they're going to look kind of funky, let's put it that way.
Well, yeah, I mean, that's really interesting because that's one thing that I've always thought about James Webb, that we weren't going to see pretty pictures. But you saying that has kind of made me really happy because, like, as an astrophotographer, I know about, taking pictures through the filters, then assigning it to RGB. And so, and one of the things that I often do is use this thing called Hubble palette, where you mess with those things so you get the greens out and it looks more golden in those. And so, will there be a JWST palette kind of way of showing these pictures to make them more accessible to the general public as pictures that look beautiful?
You're absolutely right. And this Hubble palette is not an accident at all, right? The fact that it exists and that there's kind of a look to Hubble images has been worked on by the people in outreach in as well as in the scientists for years to try to create that almost a brand identity to Hubble. It sounds trivial, but it's important because it engages the brain. You can look at it and you say, I'm seeing outer space because I know that's what Hubble does. So JWST has loads of filters and lots of wavelengths. And so actually coming up with the combination, which is the default, if you like, we're not there yet. We'll have to see what the pictures look like. A kind of a little weirdity is that because JWST is what we call diffraction limited, that means that we get the sharpest possible pictures out of it at any given wavelength. But that depends on the wavelength. So at longer wavelengths, objects, point sources, stars, will actually be bigger than they are at shorter wavelengths. On Hubble, you don't really see that effect. So when you line the images up from across a factor of 5 in wavelength, everything's pretty much the same size and it all lines up and makes a nice picture. JWST, you're going to actually, the stuff at 10 microns, the long wavelengths, or even at 30 microns, are going to be fatter than the ones at short wavelengths. So you don't want to really add them together because it might create some funky looking stuff. But this is exactly, I've spent quite a lot of time on this myself and my projects on JWST. So I'm a member of the science working group, have been for a long time. And I have guaranteed time on the observatory. So I have programs I'm going to be doing when it's commissioned. So the Orion Nebula, right? I'm going to be looking at that. And that's an iconic object. What's that going to look like? How do we assign colors to that? And I'm observing at least 12 wavelengths. So I'm going to have a lot of choices for figuring out the kind of the look, at least for my images. But you're absolutely right. It's something we don't talk about enough is why are the public engaged in what we're doing? Is it really the science story? Is it the emotional connection with saying, I could be there, that's a place in outer space, that if I would only go in a spacecraft, I could see that, which isn't true at all. I mean, one of the great fallacies about the Orion Nebula, for example, is if you got in a spacecraft and flew right next to it, it would look as grey and as faint as it does to the naked eye today. I mean, because it never gets any brighter. It just gets more spread out. You get closer to it, it gets brighter because it's closer, but then it gets more spread out. So if you were standing next to the Orion Nebula, it wouldn't look like anything like those pictures that Hubble's taken.
So like Star Trek when they dive into a nebula. It's
it's not that they're untrue. They're not wrong because all the colours are there, but they're not bright enough for the human eye to be activated. And in James Webb, of course, they're at wavelengths we can't even see. So there's a debate: is that fake? No, it's not fake. It's scientific.
It's an interpretation.
Yeah,
there is, but these days with any digital camera, it's an interpretation. It's a digital interpretation, and you can move wavelengths as well, and you can move the exposure, and you can. It's not. It's, even when you were doing film, you were doing dodge and burn, right? So you're always modifying the photo in one way or another.
Here's the thing I did this week, actually. I took a friend... I took my telescope round to a friend's house and we looked at Saturn and Jupiter because they're up at the moment. And they'd never seen it before. And you can't replace photons hitting your actual eye, right? That's it, And I suppose that's the whole thing with Hubble, is it kind of... like you said, it did do something where it for the first time people were able to feel as though they were seeing these things with their own eyes. But you can't replace that non-digital experience, right? The human eye thing.
I mean, it's interesting because there are telescopes being made today for the amateur community which are digital right from the outset, right? They just basically have a screen, you point, and of course they're more sensitive than the human eye, so it mediates that experience even with a little telescope on the ground. I think that's a bit wrong. But let's go back to this point, because I think you raised it, Julio. Now, it changed outreach in astronomy. Yeah, kind of, but why, right? And the important point to remember is that Hubble was broken when it launched, right? Hubble did not take good images. So a huge amount of effort was put into image processing to try to make the best possible pictures out of it when it was broken, through deconvolution techniques to get rid of the big halo that was around everything. And there was a huge push because Hubble was a joke. Hubble was an utter failure in the eyes of the American public. It was ridiculed in cartoons. It was laughed about in TV shows. I was living in America at the time. I mean, it was, this was the end of NASA, right? And so there's that redemption, fixing it and making it work again. But in the meantime, before it was fixed, a huge amount of work had gone into building up PR around the mission to make sure that people, when the pictures came, even the not so good ones, that they were sold in the best possible way. And that revolutionized the way that we did astronomy outreach. It had always been done before. Pictures from Kit Peak from the 1950s, right? Or David Malin's photographic work from the 80s. Beautiful stuff, but never quite penetrated onto the walls of schools and so on in quite the same way. So Hubble did that first, and it had a huge machine to say, we are not dead, we are back. Here it is. Here is the best stuff you've ever seen. And this came to certain key images as well, the Hubble Deep Field. There are all those galaxies, and there's no stars in there. Every galaxy has got 1 billion stars. The Eagle Nebula image, the very famous one of the Pillars of Creation, by Jeff Hester and Paul Scowen, which is all green and blues, and it looks like an undersea scene, right, with these pillars. Complete nonsense, right? Doesn't look like that at all. It's red. And in fact, I remember meeting David Malin shortly afterwards, and he in Australia, and he said, "I hate these guys, right? They've, it's terrible what they've done, because that's absolutely not what it looks like." And I remember being in a shop at some point.
But it's beautiful.
It's beautiful, but it was also oversold, right? This Pillars of Creation. We're seeing new stars being born. It was in the center of Time magazine. And I was in a bookshop somewhere, and I was, I had actually imaged this stuff in the infrared. I'd worked on this region before. And somebody opened up the Time magazine. I was standing in the bookshop, and they went, "Oh my God, wow, look at this. It's amazing." And it says here on the side, you can see all the new stars being born. It's creation. And I sort of looked and I said, actually, not really, right? I mean, sorry, you can't actually see them in these images. We know perhaps some of them are there. And it was a very weird sort of interpretive moment. But that's what PR is about sometimes, isn't it? It's about slightly extending the message to make an emotional bridge to people, to make an emotional connection, that they feel that it's kind of, they can be there, or it's theirs, or they've had some kind of truth revealed to them. But the danger, and you know this working in comms, the danger is going too far. And if you go too far...
Yes. Oversimplification.
Yeah, so for example, again, mid-90s, when Hubble was in its full pomp of we're fixed, we're making beautiful pictures, there was a real temptation to oversell them. And I was in a conference somewhere in the US speaking, and I spoke to Kathy Sawyer, who was a journalist for the Washington Post. And she actually made the point, she said, I'm getting a bit sick of some of these press releases because they're going too far. We know this is great stuff. We can see this is great stuff. But there's a real danger here that they're overhyping and overselling, and that the rubber band will snap at some point. And I think that's a lesson I took away from that, is always be solidly grounded in the truth, right? So as an example, to sort of jump to the future, when we made all those lovely cartoons about Rosetta and Philae in the in 2014, 15, 16, anthropomorphizing the spacecraft, bringing them, having an adventure. The very final one ended up with Rosetta landing on the surface. Okay, so Philae was already there from 2014. Rosetta was crashed onto the surface in 2016. And we had so many kids write to us say, please make sure in the cartoon that they land together, that they cuddle up with each other for all of time. And we talked about it, and we said, look, we said we can't do that because that's not true, right? They will not be landing in the same place. So let's not make PR for the sake of PR. Let's use it as a way of engaging, but let's not go too far with it. And we have had endless debates in ESA, and you know this.
But look at the effect of that just you saying that made me tear up a little.
Well, yeah, you can have your cake and eat it, right, in that sense. You can make the emotional bridge and get it right. And so, the final cartoon shows Rosetta landing in the foreground, eyes closed, and then Philae is, a few hundred meters away. In reality, it's more than a kilometer away. But they were not together. We didn't bring them back, which would have been tempting. And that's what kids wanted us to do. But we thought, one day you're not going to be 7, you're going to be 25, and you're going to want to know what really happened.
Well, I mean, I'll give you a good example of where sometimes like hyper-realistic pictures do sometimes make outreach harder in the fact that when the black hole picture came out recently, I knew that when that was going to come out, that it was going to be disappointing for anyone who didn't understand what actually was on display there, right? So, I mean, because we're so used to, like the Pillars of Creation, it's like, well, it better be better than that. Well, it's not going to be.
So, yeah. You're completely right. And I think, so my reaction to it was, I remember seeing it kind of a couple of hours before the release, because the guy that was doing had made the PR images, as in using the data. It was at a meeting with him, and he said, look, this is what we're going to be releasing. It's like, wow, right? Wow. And yet, absolutely, then for the next day, people were saying, oh, boring, it was just this fuzzy. Why? And in fact, it's interpolated as well. I mean, there are more pixels in that color image than are really in the real data. So it's not even a kind of a pixel by pixel representation. It's not an image created with a digital detector, so you can choose that scale, you can choose how you make it. And then later on, I think was it last year, they put the magnetic field on, so they'd measure the magnetic field around the M87 black hole. And there was a lot of discussion. Actually, that's not the magnetic field at all. It's the electric vector. It's orthogonal to the magnetic field. And so, but it looked nice because it was flowing, right? I mean, it looked like it was flowing around the black hole. So, and I'll say the one, and I'll piss off some people that I know quite well who do really amazing work. But a lot of the pictures coming back, from Juno, of Jupiter. Jupiter's pretty flat and boring. I mean, it's beautiful, it's glorious, but actually there's not much contrast on the surface of Jupiter locally. But you can crank it up, right? You can crank up the color contrast, you can crank up the dynamic range contrast. You make these astonishing pictures which bear no real relation in color terms and contrast terms to reality. It's all there, but it's like me going on Lightroom and taking a picture of and I do it all the time, as Julio knows, the glorious Netherlands sunsets. Well, I get home and I push it, right? I mean, because I'm doing art. And then people say, wow, what a beautiful sunset. And I'm saying, well, yeah, actually didn't quite look like that, but I'm engaging you now, right? Because I'm not saying I'm lying, but I'm an artist at that point. Right.
But it's almost like social media, isn't it? It's almost making us disappointed in the life that we have. Like looking out to looking out to a sunset and going, God, it's not quite as good as Mark's one that he posted on.
But I think, I know Julio doesn't want to go there, but it's just it is exactly a problem we have today, right?
Yeah.
We set the expectations and they cannot be met. And that's across the board. Every kid wants to be an astronaut. Every kid wants to be a Premier League footballer or whatever they want to be. And it's
not that I don't want to go there. It's just that if you push me in that direction, I can start.
Julio's the biggest
with my thoughts on social media.
Julio's the biggest grouch ever. I mean, I've got to rein him in all the time, Mark.
Yeah, no.
No, I mean the whole everyone has to be first at something all the time, and everyone has to be the biggest at something all the time. So I really,
But
you know what?
It's a concern. It's a huge concern, and we'll come back and talk about it another day. Yeah.
I mean, Mark, but we have been talking a lot about all this photo editing, and you had a busy week, by the way, editing. And there were 2 flybys this week of 2 ESA spacecrafts of Venus. So, and I know you were very involved with that. Maybe you can tell us a little bit about it.
Yeah, sure. So we have 2 missions which were launched. One just before, in the end of 2018, Bepi Colombo, which is a mission on its way to Mercury, and then beginning of last year, Solar Orbiter. So Bepi Colombo is a joint ESA-JAXA mission between Europe and Japan, and Solar Orbiter is ESA-NASA, so Europe and the US. And both of them use what we call gravity assist maneuvers, so flybys at planets in order to get to their destinations. They're doing it differently. Bepi Colombo is going to Mercury, which is in the inner solar system, and you can get to Mercury really quickly, right? You get to Mercury in 3 months if you want to, but you just wouldn't stop when you get there because the gravity of the sun would pull you in so hard you would just fly straight past. So we're having a very complicated itinerary of flybys and propulsion sectors with Bepi Colombo. It's taking 7 years instead, and that 7-year journey involved. Launch in October 2018, return to Earth. So it's kind of crazy. Fly away from Earth, come back to Earth. But then you use the gravity of Earth to send you to Venus. We did a gravity assist at Venus last year, and we did the second and last one just earlier this week. But 33 hours before Bepi Colombo got there, Solar Orbiter got there for its second flyby. So the timing was just coincidental. They weren't there at the same time for any scientific reason. Solar Orbiter.
You don't want to put them to hold hands like
Rosetta and Philae, no. And Solar Orbiter flew by at about 8,000 kilometers above the cloud tops, whereas Bepi Colombo this time on its second flyby was only 550 above the surface. So it's very close in. Solar Orbiter will come back to Venus repeatedly. The reason it's doing that is it's using Venus to trim its orbit so that it can basically turning it from originally a circle into an ellipse, and so that it can go close into the sun, then come far out from the sun again, or out towards Venus, and probe the solar wind and the environment that the sun sets up in the inner solar system as a function of distance. So you want to go in close for the best pictures, see the solar wind close up, and then come back out again, go in and out, in and out. And also, using Venus, we'll not only be able to make the orbit get closer to the sun, but we are also going to kind of fly under Venus and get lifted up out of the plane of where all the planets orbit. This is what we call the ecliptic. And that will allow us to actually view the sun from above. And that's never been done with imaging before, to see the sun, the poles of the sun, the south and the north pole. We have some very kind of grazing incidence pictures where we have some hints about what it might look like. But unless you can get higher up and look down, we'll be about 30, 35 degrees looking down. We'll be able to see the poles in much more detail. And they may not be the same as the rest of the sun, right? There's a rotational axis, and we know that on Jupiter and Saturn. There are huge storms on Jupiter and Saturn at the poles. There's a hexagonal storm at the north pole of Saturn, for example. Now, I'm not saying the sun will have that, but you can't, without going and looking, you can't know what it looks like there.
Is this the first time we're going to have an image of the poles of the sun?
We've managed it by the fact that we've done it with satellites near the Earth, because there are times of the year when the Earth's orbit is slightly tilted up and slightly tilted down relative to the solar rotation axis, slightly. And so we've been able to take grazing incidence images and then kind of reconstructing them and saying, what would it have to look like in order that when I project it at that really shallow angle, I can see these features. So it won't be exactly the first, but they will be, infinitely better. We've flown over the poles before. We had a mission called Ulysses, which was in orbit for many years until 2009 or operational. And that actually flew over the poles of the sun. It went out to Jupiter. It sounds crazy. It went all the way out to Jupiter, used the massive pull of Jupiter to then slingshot us up perpendicular to the solar system and then execute a giant circle around the sun at 90 degrees to the rest of the planets. But it didn't have cameras on board. So it was able to sense the solar wind and so on, but it was launched. When was it launched? 1990. It was launched on the space shuttle. And that was a ESA-NASA collaboration. So so Solar Orbiter will come back to Venus repeatedly. And in fact, this latest gravity assist now puts us on track for starting the full science mission of Solar Orbiter. So soon, at the end of this year, we'll be actually start turning all the instruments on. We've done some science, we know the instruments work, but we haven't been in the right orbit to do the full science. Bepi Colombo, so Solar Orbiter did have one camera on board which saw Venus fly by quickly, but the main sun imaging cameras weren't on. They're not designed for that. And Bepi Colombo, its main camera wasn't available this week either, because Bepi Colombo is a stack of 3 spacecraft. There's a big propulsion module at the bottom, and then there's the European Planetary Orbiter, which sits in the middle, with most of all the instruments in, and then at the top, a Japanese magnetospheric orbiter. And when we get to Mercury finally in 2025, in the final orbit, they all separate out. We dump the propulsion module, don't need that anymore. Then the two orbiters go into their different respective orbits and start doing science. And then the main camera will be revealed, because at the moment it's sandwiched between the spacecraft as protection. So we'll be using engineering cameras this week for this flyby. They were put on board 3 black and white cameras, fairly low resolution, to take pictures of bits of the mechanisms deploying when we first got into space. The high gain antenna, the solar arrays, the booms. And they all work, but the cameras are still operational, so we can use them for these flybys. So we took a sequence of images starting on Monday as we were approaching Venus from the night side. We were kind of keen. Well, actually, they weren't even designed in. There were no images designed for the night side. So I actually asked on, I think, Sunday, can we insert some images to take pictures of the Venus night side? Because there is this long-standing myth or legend about what's called the ashen glow.
Yeah.
Is there a glow from the night side of Venus? Certain observers have reported it, and it made you have to be a contrast issue in your telescope, that it's an optical effect in your eye. Other spacecraft have never seen it, but is it to do with lightning on Venus or something? So I thought, well, we're doing it, so let's just take some pictures. So I managed to get 4 images of 20 milliseconds each inserted into the timeline on Saturday or whatever it was over the weekend, just before the flyby. They don't show the ashen glow, so
how disappointing.
they show a lot of ghosting in the optics from very bright Venus just off the side. But it's kind of cool, because at some point you see the limb of Venus appearing in the images. And then we flew right past 550 kilometers away, and Venus just fills the field. It's just a blank, bright wall. And Venus, with its very dense clouds, doesn't allow us to see the surface. So we just see a white wall of clouds. There's no contrast in them. We're not seeing any structure, which is what we expected, right? If you want to see clouds on Venus, you have to go to the ultraviolet or to the infrared. In the visible, it's just a flat white wall of sulfuric acid clouds. But then as we departed, we could kind of look back and see Venus disappearing, and we maneuvered the spacecraft. We moved the high gain antenna around to point to Earth. The spacecraft got reoriented. So Venus moved around, the mechanisms moved around. It kind of makes for this sort of poetic, this is you. You're in space. You're on a spacecraft actively looking at Venus. So I helped the team. I had worked on the other flybys on the images, and they said, would you want to come in and work on putting the images together into a movie? So we did that, and we were reducing the images as they came down. It's always a thrill, right? It's one of the biggest thrills in my life for people to be, you're on a call like this. People are saying, oh, the image is coming down. You'll see them they're in the box now, and you grab them, and there it is, and there's Venus. And then the next one comes, and it's moved slightly, and there's nothing to beat that. And it's a privilege, right? So I wish in some ways you could share that with the world, but there we, let's get it out, let's release it, let's put it to the world as soon as possible. And I was talking to one of my artist friends last week, Anna Phoebe. She's a musician who's worked with us on Space Rocks, which we haven't talked about. Maybe we won't have time today, but this is an outreach.
Maybe a little bit later.
We're an outreach project we've been doing for a number of years. And so I've been talking to Anna about various things. She's a good friend. She's a violinist and a composer. She's worked with Jethro Tull and Roxy Music, and she was in the Trans-Siberian Orchestra, and she has this great solo career and a band career with a band called Ava Waves. And so I was chatting to her about projects, and I just had the team meeting about Bepi Colombo, the imaging, and I thought, you know what, Anna, would you like to write a soundtrack for this? And she immediately jumped on it. She's done other things for us to do with climate change and so on, so she's kind of tuned in to the whole art science, how to use music to make people feel emotional or a connection. And so what we were able to do was send her a movie which was a simulation of what we expected to see out of all of the images, because, of course, the trajectory had been designed by the flight dynamics people at ESOC in Darmstadt so that we would fly through exactly the right place at the right time to then get to Mercury as the next destination. And the images are all kind of simulated. This is what we would see in this image. This is what we see in the next one. So I could send her that timeline, and she could design her music to fit that timeline of images. And she told me when we got the real images and I sent her the movie, she said, God, it looks exactly like the simulation. And I said, well, good job, really, because if it hadn't, we would have been in real trouble. But yeah, she was just, again, it was that thing, blown away. You guys can predict this stuff. Physics works, right? And it's not always obvious to people that physics works, but in that very simple case, yep, we designed the trajectory. We took the images when we expected. They look like we thought they did. But she's written this lovely piece of sort of electronic. Well, she's written music over the top. Weirdly, I sit in my shed out here at home, and I play around with GarageBand and other things and synthesizers and just make electronic noises. I can't play music. I love music, but I have no talent for playing any instrument. But I can make sounds and just sit out here for hours moving synthesizer buttons around and making weird bleeps and bloops. And I sent her some of this stuff. We actually had a single last year. You go on Spotify, look for Anna, Phoebe, and myself. I did almost nothing. She did all of it. But I sent her some more sort of soundscapey stuff, and she built that all in. So when you listen to the soundtrack, all the kind of electronic, clanking kind of sounds of the spacecraft, that's my stuff. And then she's built this beautiful violin and piano piece over the top of it, which is kind of the beauty of space. So it's the mechanics of how do you do this. Here's a machine in space. That's the kind of the boom of the silence of space, the conceptual electronica sound of space, and then her beautiful music over the top of it. So really pleased to do that. And then we had a bit of an all-nighter because I had made the movie. She synced the music perfectly to it. Then we had to remake the movie in order to put all the timestamps and labels on it. And the movie just never lined up. And we just went all night long saying, no, you need to move that by 1 second so that cue in the music hits exactly when that picture shows. So at 2:00 we said, we'll do it tomorrow morning. So that's why it came out a day late, because it kind of took us a bit of time to line everything up exactly.
The moment you mention...
It's a wonderful result.
The moment you say the word video, it's going to take 10 times longer than you planned for. I mean, that's like, it's like so annoying.
That's the reason why this podcast is audio only,
and
right?
no, absolutely. Yeah, I've even started YouTube projects and it's like, no, okay, let's go back to audio. Let's just go back to audio only. Before Julio steps in, as a kind of music and space, there is a really strong connection, isn't there? I mean, because we've had Brian Cox on the show, and obviously he's a keyboard player, a bit of a synth guy like yourself, and then obviously there's Brian May and people like that, and it seems to me that there is this huge connection between musicians and space.
Let me add to that, because you're too humble. There were two musicians as well, Matt Russell and Jamie Franklin, that many years ago, these two musicians that had love for space started a podcast. And the podcast was so good when I listened to it that I got more and more involved. I wanted to help them. I wanted to support them. The fact that today I'm helping as well here. So yes, this connection between music and space is
in fact, weirdly, that was my choice when I was doing my degree. Do I do infrared astronomy at Imperial or acoustics at Salford? And I chose acoustics at Salford, so that's where my path diverged off the thing. But the funny thing was, the only reason why I didn't do infrared astronomy at Imperial is because my hair was too much like Brian May's, and it would be too embarrassing that everyone would think I was just copying him.
Yeah. No, I know quite a few infrared astronomers from Imperial College. My PhD examiner, Viva, Bob Joseph, he was an astronomer from there. And so I won't say you chose wisely. It was Imperial. You'd have been better off doing infrared astronomy at Edinburgh. But anyway, look. So
if only I'd known that was an option. Damn.
So I'm a huge music fan and have been sort of, I suppose, for me it was classical music in a weird way. My parents, I think we had a copy of Holst the Planets at some point when I was young, and I listened to that. And my musical tastes in a weird way were very, very, very vanilla when I was young. I mean, this was the time at school, the kids were listening to the Bay City Rollers, and I thought, I just don't get that at all. And I was listening to Radio 1, and I had a little hobby of recording the number one song each week onto a tape, as if that was some kind of record of music, as if nobody ever thought the internet would come along and every single song and every single Top of the Pops episode would be watchable ad nauseum, right? It sort of felt I was doing something for posterity. But yeah, everything changed for me when I was 16, and it was it goes actually a little bit further back. My dad worked. He ran a training college for a big company. So he worked for this company, and then he was put as manager of this big training college where the salespeople would come in and be residentially trained. And he would bring music home, just albums and so on. We would play them at home, and he brought home a copy of the Yes album. So this is from 1971 or so, and I suppose it was probably 72 or 73. So it was 11 or 12. It was on a cassette. And my mum had a mono cassette player for her work, and I would just obsessively listen to this thing sort of under the sheets at night, just to listen to the album. And I could quote you every single note. But I had no idea. I was so naive about music that I had no idea that this band actually, what was a band? I mean, who were, kind of, if they weren't on Top of the Pops, they didn't exist. There were much smarter kids at school than me that were already following Led Zeppelin and these bands, Genesis and so on, but I just kind of wasn't. And so I missed sort of a few years of their absolute prime if I had been clued in. But then on 16 we went on a school trip, and we went up to North Wales to go climbing, and one of the kids on the bus, one of my friends, he was one of the cooler kids. He had a copy of the NME or the Melody Maker, or whatever, the music, whichever one it was. Big open. He was looking. I looked over his shoulders from the coach seat behind, and there was this band, which, yes, they released a new album, and this is called Going for the One, 1977. And I sort of thought, oh, what the hell? I've been listening to that. Their previous album. Of course, I missed all the ones in between, Close to the Edge, Tales from Topographic Oceans, Relay. I mean, it was a bloody hell, right? And so he handed it to me, and I read this enormous spread about them, and weirdly, same copy of the newspaper. There was a couple of pages later, there was a little film review of a little film that had come out in America that was making waves. Nobody expected it to, and it had a picture, tiny little picture, a few square centimeters of what looked like the most giant spaceship you'd ever seen. And because I was a sci-fi person, I thought, wow, well, you've got to go and see that as well. It was Star Wars, and it was an X-wing, actually. It wasn't a big ship at all. But I went and bought that album, and the next day or the next week when we got home, and just listened to it constantly, and then got into music. So it was always classical, prog, and space in a weird way, or the kind of cosmic consciousness plays a big role in both classical music and prog.
Yeah. Well, Starship Troopers definitely on our playlist that we have of space songs. Yeah, the Yes album and Going for the One are two of my favourite albums. By the way,
there you go. So Julio, you can leave the room now. We can take an hour to discuss. No, we'll stay on track.
I get hypnotized when you guys start with that. I love it. I was born in '79, so anything that comes from music of the '70s, I listen to it. I love it, but I didn't live through it. So I like to learn.
It's different. But let me fast forward. So, I mean, I've always been interested in music, but I had the opportunity to start doing something more fundamental with space science and music when the Rosetta mission came along. So Rosetta just magically engaged the world. I mean, a lot of work went into that. It didn't just do it. I mean, a great team of people working on creative ideas on how do we get the public interested in these two little robots. Well, I've given the game away. Little robots. They're just chunks of metal out in space. How do we make them little people that are doing an adventure, and how do we engage in this whole thing of landing on a comet? And alongside all of the other things, the science fiction film we made, the cartoons that we made, all of the science information we put out, we had lots of musicians who were very interested and motivated. And one of the key ones who had been involved with our astronauts a little bit earlier on was Vangelis. And of course, Vangelis, as the composer of the soundtrack to Blade Runner, Chariots of Fire, many other things, he's a big space fan, and he always has been. And he, through the connection we had through my colleague Carl Walker, Vangelis just wrote some music for Rosetta, and it was sort of released on the day of landing of Philae. He later on made a full album, but we had lots of other musicians. We had a classical album made. People made it. We didn't pay for any of this. People just were inspired. the soundtrack album for our science fiction film. And at some point, kind of long story, but I got in touch with this guy called Alex Milas, and Alex was at that point the CEO of Team Rock in the UK, and they're a company that published lots and lots of big music magazines, Metal Hammer, Prog Magazine, and others, Classic Rock. And he had been the editor of Metal Hammer. He was linked in through Matt Taylor, who was the project scientist for Rosetta. And he's a heavy metal guy, right? And he's got his long, dark hair and big beard, very, satanic, the Dark Lord. And I was a bit scared of him, I have to say. I thought, just heavy metal, it's not really quite my scene. And he's way too intimidating. But Matt said, you've got to meet him, right? He's really interested in this stuff. And he has a degree in archaeology, so he has a science background, and then moved off into the music. And then when I was introduced, we just sparked immediately. We had so much in common interest. And Alex had this idea about throwing a kind of farewell party for Rosetta and Philae at the end of the mission. And I had the idea that we needed to take all of this wonderful outreach that we were doing, we needed to take it to the public. We needed to have live events where we could get scientists and artists and musicians to come together and not talk separately, but talk together. And what's the mutual inspiration and the creativity and the imagination that arises in that cauldron between viewing the universe, exploring your inner universe through music. What are your hopes? What are your fears? And it just came together. And that's when we created Space Rocks. And Space Rocks took us about a year to get it off the ground. Bunch of legal stuff we had to get sorted out, which was tiresome, but had to be done. And we had the first event in April 2018 at the O2, so the Indigo at the O2 in London, the Millennium Dome, as many people used to know it. And we had, some great bands playing live at the end of the day. We had Lonely Robot, who's friends of mine. We had Charlotte Hatherley from Ash playing a kind of a sci-fi inspired set. We had Arcane Roots, brilliant band, unfortunately defunct now. We've actually had trouble with two of the bands we've had in Space Rocks have since become defunct, and I think we're kind of the kiss of death somehow. But But earlier in the day, we had kids in, and we had Tim Peake talking about his experience on his flight Principia to the space station. We had people talking about dark matter. We had people talking about Rosetta. Matt gave us a talk. And then we had a middle session where we were kind of more teen-oriented, talking about climate change and talking about, a discussion session, basically, a kind of on-stage, people talking about interesting topics. There were stands, there were people could go and see stuff during the day. It wasn't the same audience during the day necessarily. Maybe some people did the whole thing, but it was designed that it was kind of, you could come in for the kids bit, you could come in for the gig, you could come in for the middle. We did another one back in London, September 2019, sort of bigger and better. And Brian May came to the first event, I forgot that. Then in between, we were at the Latitude Festival. We did Aztec Open Day. We had half of Marillion came to the Aztec Open Day with Rick Armstrong, who's the son of Neil Armstrong, which is kind of cool because he's a big Marillion fan, and these things all just line up somehow. Weirdly. And then of course the pandemic hit. We were about to, without giving too much away, this picture, which you can see behind me, but the audience can't. On the podcast, I've got a Zoom background with a venue which we went to visit at the end of 2019, and it's not in the UK, where we may do a future Space Rocks event, but then all kind of, we had to put that on hold. So what we did in April last year was start an online a live stream. So we do video, and we do it through Zoom, and every week or so, I think roughly, we've done 57 episodes now. We bring in guests, much like you do, and we talk about, we have musicians, we have artists, we have writers, we have filmmakers, we have actors. We've had Anthony Daniels from Star Wars, C-3PO, Trisha Helfer and Katie Sackhoff and Tamo Penniket from Battlestar Galactica, Shohreh Agdashlu from The Expanse. We've had Vangelis on, we've had Samantha Cristoforetti talking to Katie Sackhoff from Battlestar Galactica, right? Kind of that mashup.
That's pretty cool.
That was a good one. That was a particularly good one. I was watching. It's mind blowing.
Yeah, I mean, but they had met before, and when I asked Samantha to come on, she said, "Yeah, well, I'd like to speak to, if you can do it, arrange to bring on somebody from that world because I'd like to have that cross connection." She's a big Star Trek fan, so she wore Star Trek uniform on space station at some point. And that's sort of with Jason Isaacs, who is Lucius Malfoy from the Harry Potter films, but also was a captain in the most Lorca in the Star Trek Enterprise recently, and he's been a great friend. I mean, he's done loads of things with us. He came to the Aztec Open Day. He's been brilliant, and I think that's the thing, is you find people who see the potential of having a discussion. Not that they're super space geeks necessarily, but they can see the crossover, that the worlds they live in, that talking about science and how science has an important role in our lives, culturally, sociologically, and that, you can't ignore science. You can't deny that a vaccine works because it suits your cultural agenda, right? I mean, these are people, sensible, brilliant people in their worlds who are sort of saying, well, we're aware that your world is somehow vilified by some people, right? But we want to help you break those barriers down, because the world as we know it is not going to survive unless we take on science and say, this stuff works, right? We are not going to solve climate change by ignoring it. And so I think this is really important from our side to contextualize ESA, the European Space Agency, not to just be kind of geeky and say, hey, look, we've got a piece of metal in space that does this thing. Why is that important to people who are struggling with a pandemic, who don't necessarily, know where the next meal ticket's coming from, right? I mean, it's a pretty tough world out there, right? If your island is flooding, because of climate change, do you really give a damn what's going on Mars? So in a way, ESA is the gateway to that. We're engaged in those things. We're engaged in climate change. We're engaged in Earth observation. We're definitely doing that. But it's a gateway drug a little bit as well. It draws people in to have a conversation about the universe. But the same laws of physics that apply out there in the Orion Nebula apply right here on Earth. And you can't have one thing without the other, right, in a way. So I've been thrilled by the conversations we've had. And as I said earlier on, I love to take it off-piste as much as possible. If people come in and say, what's this got to do with space? It's like, well, listen, I mean, it's not only about geeky space stuff. It's about everything in the world that wraps around it.
Yeah, I mean, as a lecturer, the one thing that when you're talking to students is, it's not really. I've got this philosophy that it always sounds very cheesy, but it's like, if you want to teach people how to build a boat, you don't teach them how to build a boat. You get them to yearn for the ocean, right? And I just think it's so cheesy, but it's so true, that if you can enthuse people about a subject, it's like, that's what I love about Richard Feynman. It's like, let's face it, the work that he does is impenetrable to the normal person, but the fact that he plays bongos and does life drawing and is just this larger than life character makes it more accessible. It's like you said, it's the gateway drug into being part of that, and realizing that scientists are human beings as well, and that there's more to it.
I think that's an important point, actually, because it's not only about giving. It's not only about us sort of, in a way, communicating our message. It's also about taking, and I don't mean that in a negative way. It's about us seeing that our world fits in a bigger way. So we've had some artists in residence, for example. We're about to start a new artist in residence project, where it's vital to us that we bring the artists in, that they talk to us about what they're doing, and that they can contextualize what we take for granted, right? I mean, the stuff, the amazing machinery we have down the hallway at ESTEC with the satellites, those digital bits that flow back from space after these enormous machines have chucked bits of metal into space, right? We take that for granted because we kind of have to. It's what we do. It's our job every day. But the artists can come in, and I'm not saying they're being wild-eyed and saying, wow, you people are amazing. That's not so valuable, but it's being able to place it in a much broader perspective about the way the world actually works. And I think we learn a lot from that as well, because it makes us better communicators, I think, but it also opens our eyes to, partly the privilege that we have, but also the responsibility that we have, right? I mean, we're all civil servants. We're paid by the taxpayer, and they need to know what we do, but not in a sense of, we need to tell you why what we do is important, but also a bit of humility. It's like, well, there are bigger problems as well. And how do we use the skills and the talents as human beings to help you And not artificially either, not saying, space can solve every problem, because it patently can't. And that, I think that's something I rail against a bit is, space for you. Space will be the best thing you've ever done. Invest in us, because that's a bit sort of, selfish. So I think, working with artists, working with musicians, working with creatives, well, many of us are too, I think, as well. And there's a commonality. I mean, what we do in science and what we do in engineering is a creative business to begin with. It's not, just following rote rules. Do this, do this, do this. Because if it does, we wouldn't be making any discoveries. We wouldn't be making any advances. We have to find the way. Same with artists. So for me, Space Rocks has been enormously, motivational as much as it's been sort of productive. And in fact, over the last year, it was a huge sort of psychological boon to be able to, as we've all been in lockdown in various kinds, still get out there and talk to people and be inspired by what they're doing. We had a conversation just a couple of weeks ago with Jeff Mayno and Nicola Twilley, who are science writers in the US, based in the US. And they written a book about quarantine and the historical origin of quarantine back in Dubrovnik in the late 1300s, and the Empire of Venice, and how quarantine has been used over the years, over the centuries, to prevent spreads of pandemics, and how the lessons have been lost and then learned and lost and learned, and also how that applies to outer space, right? So bringing back organisms from outer space. Do you want to pollute the Earth? Or what about the other way? If we go to Mars, should we put our bugs on the surface before we know there's life there? And there are just many issues there that I hadn't really thought about in detail. But it's just brilliant to bring people in like that. As you know, I mean, you've had a huge array of great guests, and yeah, it's, as I say, it's sort of. Although I've been sitting in my shed the whole time doing this, I feel like I've sort of been around the world with many thrilling people.
Yeah.
They pull you into seeing things a little bit more from their perspective, and they make you think of things you see every day or that you do every day at work with a completely new angle, a completely new
absolutely.
way. At least that's
at
least that's what I get out of doing this podcast as well.
The joy of podcast is conversations with human beings always leads to you kind of going, God, I never thought about that. I mean, like you said, like talking to someone like Kathy Sullivan, or talking to, because we had John Mitchell, who was the guy that was your first headline act. We had him on the show just because he happens to be the label boss of one of my other co-hosts on my other podcast. So it's all interconnected. So yeah, we have Matt Taylor on as well. So they both chose a song for our space playlist that we have, our Songs of Space. Do you have a song that we can add to our space song playlist?
Oh Lord, a song, about 100.
Well, you could send me the 100, and I'm sure we'll have a lot that the same. But yeah.
Yeah, I don't know what I would pick as my top choice. I mean, it'll change 3 minutes later. I do have various playlists on Spotify and so on, which I've done for this purpose before. But it's the thing that frustrates my kids enormously is that I don't seem to have any memory for mundane things like, what was the last film you saw, or I just have no memory for that. But it's kind of occupied. It's that piece of RAM is used by other things, it seems. Off the top of my head, and it's purely off the top of my head, I would probably say Mahler's Eighth Symphony.
Whoa!
I don't know if you would call that space music. I'm pretty sure Mahler didn't design it that way, but in a way, well, let me relate a little experience that I had recently, and it was with Mahler. Julio knows I cycle to work when I went to work. Cycling is my big thing, and so I cycle a lot. And it's just 12 kilometers to work from here, so I would cycle in every day. But once in a while, I have to drive. You've got a load of stuff you have to take in, or you're going on a trip later on. You've got to drive to the airport or something. So a couple of years ago, I was driving into work, and radio was on. I wasn't picking anything. It was just whatever came on. It's the Dutch classical radio station. Mahler came on. And for the space of 500 meters, and it was good, it was a straight road. I mean, I was somewhere else completely because I knew the music, and the music triggered me emotionally, but it also triggered another thought. Out of nowhere, really. It suddenly triggered the thought that the universe around me was full of Mahler. And all I was doing was driving a metal box with an antenna on it, slicing through Mahler's music as radio waves as I was cruising along the road. And that was being translated into that sound, which I was hearing going into my ears and then triggering my brain. The fact that there was Mahler out there, there was, Bob Marley was out there. One of my other favorite bands, Churches, electronica music, Frost, all of my bands, they were probably being played somewhere in the world at that moment on the radio. And it was there. It was out there. And I looked out. There was the countryside, sheep, cows, trees, fields. You can see a long way in Holland, so I could see lots of this stuff, right? Flat horizons.
And all the mobile phone calls. And all the...
Well, no, them too, right?
Yeah,
exactly.
Crazy,
the mundane and what was what's the title of that Iris Murdoch book? The Sacred and Profane Love Machine, right? It goes from one end to the other, right? The glorious to the completely. Yeah, there was somebody talking about, order us a pint of milk, dear, somewhere on the phone. But for that 30 seconds driving along that piece of the road, I was completely transported. I call it's a thing you occasionally experience when you look at a sunset or you're at a telescope and suddenly you see new data come in. I call it cosmic vertigo, that kind of sense of falling into space, into the universe. You're totally detached from the mundane. And then you snap out of it, right? It can happen at a gig. It can happen when a band suddenly gets into the groove. And they hit that moment, and you see the band know it as well, right? They know that whatever they're doing right at this moment has just connected with that audience, and everybody looks around the room and goes, holy shit. And then it goes away. It can't last forever. Like, the best euphoria, it can't last forever. And I've done...
Makes me think of mindfulness meditation as well, in which... if you hit it, you are one with the universe and you cease to exist.
Well, a lot of people call it flow, don't they? Or the flow state, or I like to call it the fleeting glimpse.
Yeah,
obviously named it.
Yeah, exactly. I think it's by no means, I think we all do it, and you live for it, right? You can't seek it necessarily; it will hit you at the moment it hits you. But that cosmic vertigo, that sense that all of that music was there in those radio waves, and then it's gone. And now I'm relating it in a mundane way. I'm telling you a story. But, the feeling of that moment, wow, right? I mean, just amazing. So Mahler's 8th Symphony for the time being, but there's loads of other stuff I could throw in.
Yeah, that's amazing. I had a similar experience about waves this week as well. I was standing at the top of the hill because I live in North Devon, looking down at the sea, and the wake of the boat, the actual wave was propagating at a different speed to the rest of the waves, and it was just like watching this really slow wave superimposed on all the other faster moving waves. And I was thinking, God, it's just that was one of those moments, bit of momentary glimpse.
No, exactly. And you can find it anywhere, right? I can go in the garden. I mean, people who follow me on Twitter will know I've been obsessively taking pictures of the
I saw them
30 or 40 dragonflies that we have out there at the moment. It's remarkable. Just on the Mahler thing, though, because it reminds me, I've heard the symphony several times live, and one of the times I saw it was the Edinburgh Festival, 30 years ago, and I was sat in the room in the Usher Hall, and there was a big audience, full, brilliant, symphony, played, done, applause, fantastic. I didn't leave, I just sort of sat in my seat. I was just, glued to my seat for another, 15 minutes. The place was empty. It was completely empty. I was just sitting there staring at an empty podium. Except it wasn't quite empty. There was a chap, I hadn't spotted him, but he was about 4 seats along from me, 5 seats along. I was so transfixed, and he was still sitting there exactly the same, just, half open-mouthed. And he got up to leave, and as he just walked past me, he didn't look at me. He wasn't really talking to me, I don't think. I mean, he just sort of, addressing the universe. He said, it's amazing to think there are people in the world that will never hear that. And then he just left. And that doesn't have to be Mahler. It can be anything. It doesn't even have to be music. It can be, as you say, finding that moment and reminding ourselves that we're just a bunch of molecules and atoms made out of dead stars and the Big Bang. And in fact, we're transparent, right? We're a completely empty space. We're emptier than the solar system. Neutrinos don't give a crap about us. They just go straight through us. And those moments of realization, and I know it's a privilege to be able to say that when you can't put food on the table, when you've got kids screaming in the next room. I know that, and there's disease in the world. The world cannot be reduced to physics as a solace, but occasionally it can help, I think, find perspective.
Yeah, no, absolutely. I mean, I think maybe you've just hit on that connection between music, art, and yeah, physics and maths, because I guess that is the human condition, isn't it? To find solace in those fleeting glimpses. What did you call it? Vertical,
cosmic vertigo.
Cosmic vertigo. Yeah, I'll try and remember that one, because I've been trying to think of a name for it, because I get it quite often.
Yeah.
That's a good name for a band.
Yeah, it is. Yeah.
Okay. Right, I am.
Yeah. I think we got to end it there. We've
mined that mine. Yeah.
It all goes down from after that.
You can't go anywhere from there.
After that, you just go down. So.
Oh wow, it's really nice to meet you, Mark. Been a bit mind blowing, really.
Yeah.
I can't wait to edit it down.
Well, I have to say, it's a privilege to be able to kind of be on the other side occasionally. I mean, we do our uplink live stream, and we bring guests in, and I'm always conscious that it's not my place to constantly yak and yammer, but I probably do. I probably do way too much of it. Alex just kind of rolls his eyes at me. And
you mentioned Alex today, and you mentioned that he's a big guy with a beard and the long hair. When I met him, he's like the gentlest, kindest person ever that I ever met.
He's brilliant.
Sweetest
he's brilliant,
guy.
And I love working with him. And he's been a huge support to what we've done. I mean, it's his thing. Space Rocks is, it's his company that runs Space Rocks, but it's a collaboration very strongly with me and with Issa. And without him, it would absolutely not have happened. He's just been awesome throughout the whole thing. And we just, for next week's guest, we've got Dirk Maggs, who is an audio producer, works with Neil Gaiman on the Sandman audio books, Hitchhiker's Guide to the Galaxy, and many other things.
Oh my God! I listened to that in Audible.
Yeah,
man, the sound. It's the best audiobook I ever.
He's the production guy behind that, and but his good friend is coming on, Dave Gibbons, who is the artist of Watchmen. With Alan Moore was the writer, and Dave was the artist, and he did all that brilliant stuff in the 70s for 2000 AD, and so I'm a huge Watchmen fan of the original book, and so it's going to be So again, it's great. It's great fun to.
It's right there. In my selection of books, Watchmen is right there. The audience cannot see it, but I'm pointing at another bookshelf.
It's not there, Julio. Don't try and impress us.
I can go with it. It's 1, 2, 3, 4.
So whatever you say, Julio, I'm going to edit it out.
Yeah,
it's exactly. It's right behind.
We need to introduce you to the concepts of solipsism. Neither of you exist. I am the only thing that exists. I've just been talking to other parts of my brain for the last 2 hours.
I am a brain in a vat, yeah. Oh, well, thanks very much.
The Interplanetary Podcast is alive!
There we go, Julio. I did really enjoy that. Thanks very much for getting Mark on the show. I really liked him.
Yeah, I wanted to get Mark on the show for a long, long time, but he's a busy guy, with all these different projects, Space Rocks, and pulling all-nighters, editing photos of Venus before they are released to the public.
Exactly. We'll stick all those links in the show notes. So if you're wondering where they all are, we'll stick them all in, including the ESA Space Rocks stuff. And I'll put in a couple of links to the old episodes that relate to the Space Rocks, like our interview with Lonely Robot and the interview with Matt Taylor as well.
Indeed. And we should probably also put a link on the show notes to his Twitter account. I mean, it's at Mark McCaughrean, but if you just if you tell me like that, it would be impossible for me to spell it.
What's the internet address to find out all things interplanetary?
All things interplanetary is at interplanetary.org.uk.
Awesome. And if you want to become part of the conversation and join us on the Discord, that is www.patreon.com/interplanetary, where you can sign up, give me a little bit of money to keep this thing going, and join all the other Spodcats on Discord.
And what about if they want to follow the show on Twitter?
Yeah, they can follow the show on Twitter at InterplanityPod. But the best place to do it is to go to the website and follow the social media links from there, or go to our link tree as well. We've got one of those, which is just linktree/interplanetary, which is quite a good one. So, I'm giving a shout out to Mark Kelly, who's one of the patrons next week. Supposed to be this week, but as he gets such a big shout out on next week's podcast, I'll leave it. But he was a legend and showed me around a brewery last week. So we've had breweries at the top end of both these shows, by the way. So obviously space and booze go hand in hand, as well as space and music.
Space, music, and booze.
Space, music, and booze.
Sex, love, and rock and roll.
Exactly. That's the equivalent, isn't it? Right, Julio, what are you doing this week? Going on holiday?
I'm on holiday, so I'll try to I'll try to improve the Spanish version of the podcast, Interplanetary. Try to get some new interviews, and
awesome.
Just enjoying the kids, enjoying the parents that are visiting after almost 2 years because of COVID.
Oh God, yeah.
No, but it's good. It's good to get the families reunited, and I look forward to spending this time with them.
I'm off.
Okay, Matt.
Bye, Podcast.
Bye, Matt.